In the previous video, you saw that you need to watch out the influential observations and outliers when you do the regression. So here there are some other questions about when you do the regression. The first one, the correlation and regression lines describe only linear relationship. The one we were studying, in other words, this linear one is describing only that linear relationship. Sometimes you may have other, like a different relationship, like a quadratic relationship or some other type, okay? But right now we are looking at only the linear, okay? So also then, so if you're going to use that, so you need to watch out whether you need to see relationship between the quantitative variables, but the results are useful only if the scatter plot shows a linear pattern. Okay, so the second one, so the correlation and least square regression lines are not resistant. Always plot your data and look for observations that may be influential. That you already have seen that. Okay, so you need to watch out that. So the third one, beware of extrapolation. So in other words, so this is a very good example actually. So if you look at the kids like age from 3 to 8 years of old kids, their height and the age. If you collect that data and run a regression, you will see that a very strong correlation actually. So suppose you run a regression line like that, you will see a very straightforward kind of a linear relationship within that range. And if you try to use that data to predict a person's height when they are 25 years of age, okay, so you're probably going to get more than even 8 feet that person's height. The problem is that, you know, the kids, you know, the growth will go down after a certain age. So they're not going to grow linearly all the way. Okay, so in other words, you cannot use that line to predict their age at 25. Okay, so so that's what that is about. Okay, so whenever you try to predict certain values, you need to stay within the X range. That's the key. Okay, so in other words, the example we were looking at before, say, so you need to stay within this X range if you want to predict that. You don't want to go outside of that, the data range. So here from this data, see this is the X, the minimum X values, and here is the maximum. You need to stay within that. So most of the time if you go outside, you cannot, most of the time you are going to end up with the wrong answers. Okay, such predictions are often not accurate. Beware of the lurking variables. Lurking variable is a variable that is not among the explanatory or response variable in a study that yet may influence the interpretation of the relationship among the variables. So in other words, most of the time it will impact the interpretation. Sometimes actually may not impact. There's another way it might impact. Always you need to look at these lurking variables. So especially right now I'm going to show you it may impact on the interpretation. Say for example, this is a very good example actually. So the worldwide AIDS epidemic and the internet use have been both exploded over the past 2 decades. And thus you could expect to find a positive association between both variables. In other words, if you collect the data, the number of AIDS victims and then internet users, you will see that a very strong correlation between those 2 variables. However, these 2 associations is purely coincidental and meaningless. There's no meaning with that. Basically, those 2 events happen almost exactly around the same timeline. That's why that association is there. Okay, so in other words, that's meaningless. Okay, so the next example, so you need to watch out this kind of lurking variables. Okay, so this one, this is a good one also actually. So the question is this one: which student scores 51 points or higher in verbal skills and 39 the question is which student scored 51 points higher in verbal skills and 39 points higher in math. Okay, the answer, the student who had experience in music. So it's some kind of article, you know, they discuss this. Actually what happened is that these people, these music people, they use that in their advertisement. Okay, to get more business. Okay, so the thing is that, so however, we could probably just answer the same question, just as well answer the student who played soccer. Actually, if you look at the connection, you know, this with that, that most probably is correct, true. In other words, this may be correct, this may be correct too. So in other words, what happened is that there's a hidden variable behind that lurking variable, which is that probably, most probably, the family background. So the kids who goes to these music lessons, take music lessons, their family background might be better than the other kids who are not doing it. So, or the other way, the income level of those people, the same thing goes with that. Okay, so in other words, that the hidden variable pretty much has more to do with that. That may be correct. We are not saying that that may not be correct, but what it's saying is that there might be a hidden variable do more into that than that is alone that. Okay, so that's why this, so they put it this way: this family background is a lurking variable that explains, at least in part, okay, which means that might be true, why the test scores are related to the experience with music. All right, so in other words, you need to watch out those kind of things. So in the next example, I'm going to show you what happened when you ignore those kind of the lurking variables. Okay, so in this example, this is a good example. So the high blood pressure and arterial stiffness are risk factors for cardiovascular disease. So it's basically they are trying to study cardiovascular disease. So the predictor variable, sympathetic nerve activity on the x-axis, that's the predictor variable. The response variable is the stiffness indicator. All right. So what they are looking at, they have the male and the female data all together. Okay. So if you so this is the data for the male and this is for the female. But the thing is that if you combine all the data and analyze it, so if you look at the scatter plot, see, there's no, this is the scatter plot, no correlation. The correlation is almost near zero. There's no pattern in there. See, this is that, if you, for this data, okay, combined data, it's almost near zero. All right. So now if you look at separately for male, so there's a high correlation, like R is 0.53, positive correlation. For the female, there's a negative correlation, minus 0.58. Okay, what happened is that when you combine those two data together, and this is almost, there's no connection. But if you separate it, that. So in other words, the gender is a lurking variable that drastically affects the relationship between the two quantitative variables. Okay, so you need to look into that. So in other words, there are more things, you just cannot just look at just the one variable alone. Actually, later on, like in right after we finish this thing, we will get into chapter more details. But I don't think we will get into, in this class, we are not going to get into several variables. But technically, you need to look into more variables. Okay, just one variable alone, if you want to handle that, you need to handle them separately. All right. So anyway, so that's that. So the next example, so cause and effect. So association does not imply causation. Okay, so this one, so in other words, a strong association between two variables is not enough to draw conclusion about the cause and effect. So this is actually a very funny example, this one. So in this example, so you can find this data in the, well, I don't have it anyway. So it's a published results actually in a Journal of Medicine. Okay, so over there, so what they are saying is that they are looking at the Nobel Prize winners, the number of Nobel Prize winners versus the chocolate consumption. So there's, but if you study that, they have the data, and then you look at it, the correlation, there's a high correlation. If you look at the number of in each country, in the population, basically, you're looking at the number of Nobel Prize winners, and the other side is the population. Okay, the chocolate consumption, predictor variable is that. So here what happened is that, so very high correlation. But the thing is that is really misleading actually, because the thing is that so is the lurking variable such as the country's wealth, probably more to do with that the chocolate consumption. Okay, so that's a lurking variable could be that way. Okay, influence both actually. Okay, influence both the number of Nobel Prize winners as well as the other one. Okay, chocolate consumption. Okay, anyway, so that's that. So in other words, you need to watch out those kind of things. Okay, so okay, so yeah, so that, so this example, yeah, so you guys read it if you wanted to. Okay, so these are another situations that you kind of may get into wrong conclusions. So okay, about lurking variables or some other factors, hidden factors. Okay, so basically really that if you see that kind of thing, you need to control those the other variable if you want to have a meaningful answer actually. Okay, that is about that. Okay, so that this one is another example. So okay, so I will put this one in your note anyway. Okay, so that if you want to, you can read it. So this is another example. Okay, so you read this one also basically if you want to. These are very nice examples actually. Okay, so it's explain about another lurking variables. Okay, anyway, so it's basically the bottom line is that you need to watch out this about lurking variables. It may explain the relationship between the explanatory variable and the response variable. The correlation and regression can be misleading if you ignore the importance of lurking variables. Okay, so that's one, and the other one is a high correlation does not imply the causation, cause and effect, the one that chocolate example. Okay, so yeah, so okay, those are the things you need to watch out. So okay, I will go into more details in that one, how to basically construct a better line. Okay, so okay, this is about this one. So let me stop here. Okay, all right. Okay.